Salam, peace be upon you. My name is Muhammad Laik Sibiki, the father of Holophase. Part 5. Constraint Propagation, when one rule forces many. Remember the drill. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, the three dimensions show themselves at once: time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. We are inside Ep.9, the Generative Grammar, where we stop only learning the alphabet and start watching the universe write. In Book 9.1, we began with a silent page, a complete initial sentence of phi spread across the manifold. Then we picked up the first two tools of production, the differentiation engine, and we used them to make the first dynamic letters appear: omega as the time echo, k as the space echo, and v as the motion echo built from their relationship. So we climbed from the root to the first living branches, and now we are ready for the first rule that binds those branches together. Before we climb into today's branch, I want you to feel the setting of this episode in your body. Imagine you are walking beside a river just after sunrise. The water is moving, but the surface is calm enough to reflect the sky. Light slides along it like a thin ribbon. Every few seconds, a small gust brushes the surface and the reflection shivers. Then the river settles and the ribbon becomes smooth again. That is the feeling of our journey in Episode 9. Rhythm and shape changing together, never permitting the surface to tell two incompatible stories at once. In audio, it is easy to lose your place. So let me place you on the master tree in one clear picture. Think of phi as the trunk of a great tree. The first derivatives are the first thick branches that split outward. One branch for time, one branch for space, and the motion branch woven between them. Episode 7 and 8 were the climb where we learned to name those branches. Episode 9 is where we learn what those branches do, how the universe actually generates its stories from a starting phi pattern. Now, return to the difference between a list and a sentence. A list is independent items. You can change one item and nothing else must change. A sentence is interlocked. Change one word and grammar pulls on other words. Constraint propagation is the moment you realize the universe behaves like a sentence, not like a list. I will carry one anchor image with you today. A hanging mobile, the kind made of thin rods and small shapes. It is a sculpture of balance. It looks simple, almost effortless. But it is only effortless because every connection is honest. If one piece moves, the whole structure must answer. Imagine you are in a quiet studio at early morning. The air is cool. Dust floats in a single beam of light. The mobile hangs in the center, perfectly still. You can almost hear the silence. Now you lift your hand and tap just one shape, gently. It begins to swing. But then something else happens. A rod above it tilts. A counterweight shifts. Far away, on the other side of the mobile, another shape begins a slow, mirrored movement. Your touch was local, but the response became global. The mobile insists on one rule: balance must be maintained. Every connection transmits the disturbance until the whole system finds a new harmony. Here is the puzzle of this part, in one simple question. When the universe produces omega and k from phi, can those new letters behave independently, or does sharing one parent force them to agree? By the end of this walk, you will have a practical skill. You will be able to recognize when a system is enforcing grammar rather than merely performing motion. You will notice it in water, in spreadsheets, in sound, in light, in traffic, and even in the way the sky's patterns remain coherent across huge distances. You will hear the sound of a rule that refuses contradiction. Once you hear it, you cannot unhear the grammar again. Now, let's name what this branch is in the language. It is not a noun, it is not a new letter. It is a grammar rule. It is the first piece of syntax. Think of a woven rug. Pull one thread near the edge, and the pattern tightens across the whole weave. You did not touch the far corner, yet it shifts. The rug is not being dramatic, it is being coherent. A weave cannot keep one corner while changing another. Phi is that weave, in your hands. In everyday language, syntax is like subject-verb agreement. If you change he runs to they, you must also change runs to run. You did not add a new word. You enforced a relationship. And once you enforce that relationship, one change forces many other changes. The sentence becomes a connected whole. Holophase says, the same thing happens to the first derivative letters. Omega and K are born from phi. That birth is not only a birth of objects, it is a birth of obligations. Because omega and K come from one parent field, they cannot contradict each other's ancestry. They must remain compatible with one underlying phi. Let me show you the compatibility rule, then I will translate it slowly into human meaning. In its simplest schematic form, it can be written like this. Dal K plus dal omega equals 0. Do not treat that as a scary equation. Treat it as a sentence in the grammar of change. It says, in plain words, the way spatial pattern changes with time must align with the way temporal rhythm changes across space. If those two do not align, then omega and K are not telling one coherent story about phi. They are telling two different stories, and the language rejects that. So here is the point. Production rules do not generate independent letters. They generate a family. And families come with family rules. Now we make it concrete by remembering what the letters mean. Omega is the time echo. It is the local bit. It answers, how fast is phi turning here, right now, along the sequence of moment? K is the space echo. It is the local slope map. It answers, how quickly does phi change from here to nearby, across the page of space? From those two, we now ask two higher questions. First, how does the space echo itself change as time passes? If the spacing of a pattern is tightening, loosening, bending, or reorganizing over time, that is KK. It is time change of spatial texture. Second, how does the time echo vary across the page? If one region is beating faster and a neighboring region is beating slower, and that difference has a direction and a steepness, that is omega. It is space change of temporal beat. The constraint says these are not independent. They must cancel, balance, or match, depending on sign conventions, because they come from one coherent parent. Why should the coherent parent force this? Here is the gentle reason, and it is one of the cleanest moments in the entire holophase language. K came from applying the spatial question to phi. K is made from phi. Omega came from applying the temporal question to phi. Omega is made from phi. So if you ask, how does K change in time? You are really asking, what is dol do phi? And if you ask, how does omega change across space? You are really asking, what is dol do phi? If phi is smooth and coherent in the region you are describing, then these two ways of asking about mixed change should agree. Space then time should match time then space. The order should not matter. It is like checking whether two translators, working from the same original text, produce consistent meaning. If they do, the text is coherent and the translation rules are faithful. If they do not, something is wrong. Either the text has a break, or your translation is failing, or you are mixing two different texts and pretending they are one. So the constraint is a coherence test. Let's translate order should not matter into something you can feel without mathematics. Imagine you are standing on a tile floor, like a chessboard. You want to reach a particular tile. You can take one step to the right, then one step forward. Or you can take one step forward, then one step to the right. In a normal room, you arrive at the same tile either way. Right then forward equals forward then right. That is what commuting means. The order does not change the outcome. Now imagine a room with a hidden trapdoor that opens only if you step right first. If you go right then forward, you fall. If you go forward then right, you do not. Suddenly, the order matters. The floor is not ordinary. There is hidden structure. Holophase uses the simple idea as a test. If phi is smooth in the region, then space step then time step should match time step then space step. like the ordinary chessboard. If the order matters, something special is happening there. A boundary, a defect, or a place where smooth grammar gives way to a different dialect. Now bring back the still pond, because it makes constraint propagation almost visible. Picture a pond so still it looks like dark glass. That stillness is not emptiness. It is a full configuration. Every point has a height, even if all heights match. In our language, that is a complete first sentence of phi. Now disturb it with a pebble. Rings ripple outward. At each point, you can describe two things at once: how fast the surface rises and falls there, and how steep the surface is between crest and trough. That is omega and k in everyday form: local beat and local slope. Here is the key. You cannot freely choose the beat field and the slope field as two independent paintings on the same water. If the left side starts bobbing faster than the right, the ring spacing and shape must adjust over time. If the spacing tightens over time, the beat cannot stay perfectly uniform across space. The surface is one sheet, so its time story and space story must agree. The pond enforces the constraint without asking permission. Now notice what propagation means here. When a mismatch begins at one point, when you shake one corner of the pond or tap one piece of the mobile, the consequence does not stay trapped at that point. The connections transmit obligation. In the mobile, the connections are rods. In the pond, the connections are the very meaning of nearby and next moment. In phi language, the connections are the derivative relations themselves. A local inconsistency becomes a demand that spreads until coherence is restored. That is why constraint propagation is the seed of causality in the grammar. We are not yet talking about light cones or speed limits. We are talking about a simpler, earlier idea. Local rules create global consequences because definitions link points and moments. Now a few lanterns to help you recognize this branch in different rooms. Hold a rope and flick your wrist to send a pulse. The pulse has a local up-down rhythm and a local slope. If you try to make the rhythm faster, the slope pattern changes. If you try to change the slope spacing, the rhythm changes. The rope refuses contradiction because it is continuous. Clap in a room and listen to echoes. If you place two microphones apart, you can measure how the timing of peaks varies across space, and how the interference pattern evolves in time. In a coherent field, those measurements are tied by compatibility relations. Again, space variation and time variation must fit one story. Look at traffic. A sharp drop of speed at a bottleneck is a strong spatial gradient. That gradient forces a time buildup of car density upstream. The details differ, but the pattern is the same. Gradients and rates are linked by a constraint that prevents impossible flow. Now the discipline. This rule is not all of physics. It is an early syntax gate. It tells you what must be true if omega and k are truly derivatives of one coherent phi in a smooth region. Later branches will add dynamics, dispersion, curvature, and topology. Today, we are learning the first grammar refusal. You cannot tell two incompatible stories about one parent field and call it one universe. So hold this rule like a compass. It does not walk for you. It tells you what direction is consistent. If reality repeatedly points elsewhere in clean data, then either the model must deepen or it must yield. That honesty is part of the language itself. One more way to say this is the constraint protects reconstructability. If you only measured omega and k, you could ask, do these measurements come from one underlying phi, or are they a patchwork? The compatibility check is like checking whether a puzzle's edges match. If they match, you can integrate back upward and recover a parent picture. If they do not, you either have noise, or you have mixed two scenes, or you have reached a place where the page is torn, what we earlier called sigma, a boundary, a defect core, a shock, and not in the ink. In those places, the simple zero form may gain extra terms. That is not embarrassment, that is punctuation, and it tells you where a deeper dialect begins. Now you might say, okay, that feels meaningful, but show me the everyday version again. Good, here is the everyday version, as a near lantern, clean and sharp. Imagine a spreadsheet. You open a budgeting sheet. Cell B10 is the total. It is not typed by hand. It is defined by a formula that sums A1 through A9. Now you change A5. You did not touch B10, yet B10 updates instantly. That is not magic. That is constraint propagation. It is the architecture of the sheet insisting on consistency. A formula is a rule that makes one cell's value depend on others. In Holophase, omega and k are like formula cells. They are defined by rules acting on phi. You cannot freely assign them both. If you change one in a way that breaks the formula, the sheet flags it as impossible. Now a second near lantern, even simpler. Think of a sentence in English. The apples is red. You hear it and your mind flinches. You do not need to be a professor. You just feel it. Something does not agree. That flinch is a human version of a constraint. It is your brain enforcing a grammar relationship. Plural subject, plural verb. The holophase constraint is the universe's version of that flinch. It says, time derivative of the spatial letter and space derivative of the temporal letter must agree. Otherwise, the story is not one story. Now let's move to the anchor image, the mobile, and connect it to the triunity. Time echo. The constraint governs how spatial structure evolves as time passes. It says, you cannot change the spacing map however you like as moments unfold. Its evolution must be tied to how the beat varies across the page. The time shadow is disciplined unfolding. Space echo. The constraint governs how rhythm varies across space. It says, you cannot have arbitrary islands of faster and slower beat without a matching time evolution of the spatial texture. The space shadow is lawful variation. Motion echo. This is where everything becomes one chord. Motion V is built from omega and k together. If omega and k could drift independently, motion would become ambiguous. A crest could claim one beat and one spacing that do not belong together, and then propagation would tear. The constraint is the guardian of coherent travel. It keeps the dance honest so that a pattern can move as a pattern rather than dissolve into contradiction. So here is the point, stated in a single breath. Constraint propagation is the rule that binds time change and space change so that motion can remain coherent. Now, we place one lantern in the middle scale, in the lab, where this is not only an analogy, but a measurable check. Imagine a laser beam moving through a controlled optical setup. You can measure its intensity on a camera. But more importantly, with interferometry, you can reconstruct its phase pattern, the thing we call phi in this language. You can do it in time frames, and you can do it across the beam's cross-section. From that reconstructed phi, you can compute omega by looking at tiny differences between frames. You can compute k by looking at tiny differences between neighboring pixels. That is the differentiation engine, but now it is sitting inside real data. Now the constraint becomes a test. If you compute k from the time series of k maps, and you compute omega from the spatial variation of omega maps, then their sum should be near zero, within your error bars, as long as the phi you reconstructed is smooth in the region you're studying. And as your measurement resolution improves, faster cameras, sharper imaging, better calibration, the residual mismatch should shrink, not stay stubborn. That is a lab-scale way of asking, is this branch of the grammar real? Now a far lantern, large scale, but still one clear image. Think of the early universe sky map, the cosmic microwave background. It looks like a soft, speckled pattern. That pattern is a snapshot of variation across a spherical surface. Even if you do not call it phi, it is still a field on a manifold. Scientists study its spatial structure, what scales dominate, how spots correlate, how patterns align. They also study how such patterns evolve in time into later structure through known dynamics. Holophase does not ask you to accept a specific cosmological model in this audio moment. It asks you to recognize a deeper grammar. If you claim one coherent underlying field description, you inherit compatibility relations tying how spatial structure changes in time to how temporal tendencies vary in space. Coherence leaves fingerprints. Now we return to the core question about phi, because this part is really asking one deep, simple thing. It asks, how do the first derivative letters stay compatible with each other so they can be reassembled into one parent story? Another way to say it is, how do we know we are not mixing two different alphabets? Constraint propagation is a reconstruction gate. It is a filter. If you claim to have omega and k from a single phi, the constraint is a way to check. Do they pass the compatibility test? If they do, your reconstruction can be integrated upward. If they do not, you either have noise, or you have a defect, or you have a regime where the simple smooth dialect is not enough. This brings us to a key idea. Constraint propagation is not only about forbidding. It is also about guiding. It guides what is allowed to happen next. It is like rails on a track. Rails do not push the train forward. They constrain the train's motion so that forward motion becomes meaningful and stable. In the same way, the constraint does not cause phi to evolve, but it constrains the derivative story so evolution remains coherent. Now let's talk about stability and breakdown, because every grammar has conditions where it holds and conditions where it must be refined. The constraint holds cleanly in regions where phi is smooth enough for derivatives to behave like honest local questions. But the universe also contains places where smoothness breaks, shocks, boundaries, singular cores, and topological defects, what we called sigma in earlier episodes. At those places, the mixed derivative commutation can fail in the naive way, not because the language is wrong, but because the sentence contains punctuation that is not smooth ink. A tear in the page changes the grammar. The honest move is to mark the boundary and learn the next dialect, not to pretend the tear is not there. Now, we bring falsifiability to the center as the moral virtue of this language. The language refuses to lie. It offers a check, and it allows itself to be broken. Here is the falsifiability claim in plain speech. In any regime where phi, omega, and k can be reconstructed with sufficient smoothness, the compatibility field C equals del k plus omega should be statistically indistinguishable from zero, after accounting for noise and systematic error. As you improve the quality of data, the deviations should shrink in the way noise and error should shrink. They should not stay structured and stubborn. Now the measurement story, told like a walk, not like a textbook. Imagine two teams in two different labs. Team 1 uses an interferometer. They directly reconstruct phase by comparing a beam to a reference. Team 2 uses a different pipeline, perhaps a transport of intensity method, reconstructing phase from how intensity changes along propagation. Two methods, two translations. Both aim to recover the same phi language sentence. Each team produces a time series of phi maps. From those maps, they compute omega and k, not by symbolic calculus, but by finite differences. Frame-to-frame differences for omega, pixel-to-pixel differences for k. Then, each team computes the compatibility field C across space and time. Now they compare. If Holophase is right in this regime, then, after calibration, their C fields will both hover around zero within their error bars. And as they improve their measurement resolution, C will shrink towards zero in the way expected from reduced noise. That is the pass. Now imagine the fail. Suppose both teams, despite independent methods, find a persistent, structured, non-zero C. It is not random. It has shape. It scales with a control parameter, like intensity or temperature, and it does not vanish as resolution improves. Then the smooth constraint is violated in that regime. The honest response is not to excuse it away. The honest response is to say, either phi is not smooth there, or our mapping between instruments and the derivative letters is wrong there, or the grammar must be refined with additional terms appropriate to that regime. If refinement fails and violations remain, then this specific grammar rule is broken, and Holophase must accept that and change. Now, to keep this grounded, let's give you recognition cues you can carry into daily life. If you notice a situation where a spatial gradient forces a temporal accumulation, you are seeing the shadow of this branch. Traffic is a clear one. If speed drops sharply at a bottleneck, a strong spatial gradient in velocity, then car density builds up over time upstream, a time derivative of density. Those are tied by a continuity constraint. The details differ, but the pattern is the same. Space variation and time variation are linked by a rule of consistency. If you notice a situation where a change in tempo across a room forces the structure of the room's activity to reorganize, you are seeing the same shadow. In a crowded hall, if one side starts moving faster, the pathways and spacing of people must adjust over time, or collisions occur. Constraint propagation is the avoidance of collision in the grammar of motion. If you notice a situation where two descriptions of the same phenomenon must agree, even when obtained by different routes, you are seeing the deeper heart of the constraint. The constraint is an agreement check between routes. It is the refusal to let space then time, and time then space, lead to different truths when the underlying object is coherent. Now we return again to the mobile, because it gathers everything into one image. The mobile does not have a central controller, yet it behaves as a whole. If you push one piece, the whole responds because of how it is built. Constraint propagation is not a force added on top of motion. It is the architecture of relation itself. It is the rods transmitting obligation. In holophase terms, phi is one continuous cyclic movement. Omega and k are ways of reading its change. The constraint is the demand that these readings remain consistent with each other, so that the story remains one story. It couples, it propagates, it forbids contradiction. It preserves the possibility of coherent motion. If we use the word energy here, we use it correctly. Energy is not a substance. It is a score, a tally, a number describing the intensity of change in phi and its derivatives. Large omega and large k mean a high score of change intensity. The score is not the player. The score is the scoreboard. Now I will give you the Zenodo connection once, because some listeners want to see the full formal backbone behind the story. If you want to see the full mathematical derivations and exact equations behind this idea, you can search for holophase on Zenodo. There you will find the scientific papers that this audio journey is built on. Now we close by placing today's leaf back onto the branch, and the branch back onto the tree. We began episode 9 by asking how the universe writes itself. We wrote the first sentence as an initial condition of phi. We learned the first two production tools, Furler and Del, that generate omega and k. Today we learned the first rule of syntax. Omega and k must stay compatible because they come from one parent. We climbed from letters exist to letters must agree. That is the birth of grammar. In the next part, we will use this agreement. We will see the first magnificent consequence of constraint, the emergence of stable propagation. We will watch how a locked relationship between omega and k gives birth to a wave story that can travel, carry identity, and remain coherent across space and time. Mandatory zoom-out reminder before we end. The language is one field, phi, plus its infinite derivatives. We are still near the trunk, in book 9.1, where the first derivatives are learning to obey grammar together. And this episode has carried us from a silent page to the first production rules, to the first constraint that forces coherence across the growing sentence. Salam, and peace be upon you.